Okay, so the big main idea today is the distance formula, but like I mentioned before we watch that awesome video, before we can talk about the distance formula, we got to talk about the Pythagorean theorem because the distance formula uses the Pythagorean theorem. So that's the first thing. We'll kind of go back through some of the things they talked about in that video. Okay, the big, most important thing about the Pythagorean theorem, the most important thing to remember about the Pythagorean theorem is it works for any right triangle. So any triangle, if it's a right triangle, you can use the Pythagorean theorem. If it's not a right triangle, you can't use the Pythagorean theorem. But if you've got a right triangle, it will work for the Pythagorean theorem every single time. Okay, and then kind of like what that video was saying, the thing that they said over and over again, they sung, right? Pythagorean theorem is a squared plus b squared equals c squared. And they talked about what a is, what b is, and what c is because two of them, don't really matter if you get them switched up, but one of them is really super important. So let's look at a picture of a right triangle over here. Let's get them labeled and talk about the ones that matter if you can switch them up with the ones that don't. So we've got these two sides here, and let's label these two sides A and B. So that little square in the corner means that that's the right angle. So A and B, like they mentioned in that video, those are what we call the legs. The legs of the right triangle are the ones that make up that right angle. They're the ones right on the sides of the right angle. These two you can mix around. If you want to be a rebel and you want to say this is B and this is A, go for it. It does not matter. A and B are interchangeable. Doesn't matter which one goes where as long as they're both legs. The one that's really important, the one that you cannot switch with the other two is C. C is the hypotenuse. And a couple things about C. I squiggle off at the end there because I don't know how to spell it. I'm just kidding. I do know how to spell it, but I ran out of room. Okay, so the hypotenuse. C. Two things. It is always across from the right angle, okay? So it's the easy one to pick out, across from the right angle. It's also always the largest side, the longest side. So if you're given three measures of a triangle and you're trying to decide which one is the hypotenuse, the biggest one, that's your hypotenuse, okay? It's always the longest side. Okay, so let's put some of this to work. So we want to find the missing lengths. So for our first one, and they're really kind of nice in your homework today. They kind of spell it out very nicely for you. Let's say we have A is 8, B is 5, and C, we don't know. Don't know what C is. So we're trying to find out what C is. So it's really nice whenever they spell it out for you like this because all you have to do is you have to take that formula A squared plus B squared equals c squared, and plug numbers in for the variables that you're given. So they tell me what A is, they tell me what B is. So if I take that formula and instead of A, plug in 8, instead of B, plug in 5, notice that the only variable I don't have is C. All you have to do is go through and simplify. So 8 squared is 64, 5 squared is 25. I don't know what c squared is. That's what we're solving for. Okay, well, we need to simplify everything else first, just like if this were an equation we've been working with before. 64 plus 25 gives me 89, which equals c squared. Okay, we haven't really worked with squared before, but we solved equations, and whenever we solve equations, we think about inverse operations. The inverse of multiplication is division, and vice versa. The inverse of addition, subtraction, and vice versa. Now, this is an operation that we don't deal with all the time, right? Squaring a number. But we have talked about it before. How do you undo squaring a number? What's the inverse of squaring a number? The square root. All we have to do is take the square root of that number, and it's going to get rid of that squared. And if I square root one side, I have to square root the other. So today, you're going to use your calculators because instead of caking this and getting the simplest radical form of the answer, sometimes it's more useful to give the decimal approximation. So I want the measurement of that side rounded to the nearest hundredth. So the square root of 89 rounded to the nearest hundredth would be what? Caleb? 9.43. Very good. Okay, yeah, you can go ahead and keep your calculators out because we'll be using them a lot today. Okay, number 2, let's try another one. This will be the last one of the Pythagorean theorem problems we use. Let's say this time A equals 6. I don't know what B is, but C equals 40. So they give me kind of different pieces of information this time, but nothing changes. If you know what A is, plug it in for A. We don't know what B is, so this time we're going to have a B squared. But I do know what C is, so we're going to plug in 40 for C, and we're going to square it. And just like before, go ahead and simplify those squared. So 6 squared gives me 36. Can't really do anything with that B squared yet. 40 squared gives me 1,600. Okay, and just like if this were a one-step equation, 36 plus B equals 1,600, I need to isolate that B. I've got to isolate that B squared. So how would you get rid of that 36? Right, subtract 36 from both sides. So I have B squared equals 1,564. And just like the last problem, how do you get rid of that square? Take the square root. So B, rounded to the nearest hundredth, would be what? What is it? 39.55. Okay, questions on the Pythagorean theorem problems? Okay, pretty easy. Has anybody never ever heard of the Pythagorean theorem? Okay, so you don't have very many of those today, but we do need to go back over those just to make sure you guys remember how to do those. So the reason why we had to do the Pythagorean theorem, I kind of already mentioned this, because the big idea today is the distance formula. And what the distance formula does, it uses the Pythagorean theorem to find the distance between 2 points. Okay, so to find the distance between 2 points on a coordinate grid. So we're talking about an x comma y and an x comma y. Okay. Okay, so let's draw a picture here so you guys can kind of get the idea of what we're talking about. Okay, so let's put 2 points on my coordinate grid. So maybe this point's over here. I don't really care what its actual coordinates are. But we're going to put a point there, put a point there. What I'm looking for when I use the Pythagorean theorem, or when I use the distance formula, is I'm looking for this distance here. Right? I want to know, in a straight line, how far apart are they? Now, if they were on the same line, right, if they were on a horizontal line, you could just count the units, right? Or if they were on a vertical line, you could just count how many steps up or down you'd have to go. But this, I can't really do that. I might be able to estimate, but I can't say exactly how many spaces they make up. Okay, so what we have to do instead, we're going to use the Pythagorean theorem, and how we're going to do that is we're going to change this into what's going to look like something very familiar. So if I draw a line straight down from there, and then a line over from here, what does that look like? A right triangle. How convenient! Because we know that the Pythagorean theorem, if I know two sides, I can find a third for any right triangle. Okay? So for this right triangle, if we say that's side A and that's side B, I could find side C, right? If I knew what A and B were, I could find what C is. Okay? Well, the problem here is I don't know what A is. I'm not given a distance. But I will be given 2 points. I'll be given the x comma y for this point and the x comma y for this point. So think about everything that we talked about in Chapter 8 when we were graphing lines, talking about slope and all those things. Let's look at what A is. What does this distance represent? James? What does this represent? Think about slope. Run, isn't it? Isn't it? I thought you said y. Sorry. It's the run, right? We think about slope, rise over run. A, that's the run. Another way we thought about the run was my change in x. Isn't that what the run is? My change along my x-axis, my horizontal change, how much it's changing from one x unit to the other. Okay, well, we know how to find that, right? We did that whenever we were finding the slope at 2 points. We looked, how are my x units changing from one x to the other? How would you get there? You guys remember doing that? We're going to be using that again today. Okay, well, on the same lines, what is b? The change in y. It's the rise. The change in y. Okay, well, now if I have numbers to associate for a and b, I could plug them into the Pythagorean theorem. So the Pythagorean theorem says a squared, but we're going to say change in x, plus b squared, which is the change in y, equals c squared. Now, most people, whenever they're talking about the distance formula, they don't use change in y and change in x. I think it's easier to use that rather than using the other method of slope. But if we remember the other method to find slope, remember where you could do y2 minus y1 over x2 minus x1. Because y2 minus y1 gives you the change in y. x2 minus x1 gives you the change in x. So most places when you're talking about the distance formula, instead of change in x, they're going to say x2 minus x1 quantity squared. And instead of change in y, they'll say y2 minus y1 quantity squared. If I want to know what c is, that's the diagonal. I haven't solved for c yet, have I? I've solved for c squared. Okay, well, how would you solve for c? Take the square root of both sides, right? To get rid of a square, you take the square root of both sides. So the distance formula ends up being the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. The distance formula that we're going to use, because once again I think it's easier, is change in x quantity squared plus change in y quantity squared. If you really like doing the x2 minus x1, y2 minus y1, I'm not going to stop you from doing that. But our examples today, we're going to use the change in y, change in x, because once again, I think it's easier. Okay, so let's get some examples going. Get to using this distance formula. Okay, I'm going to give you 2 points. I want to find the distance between the 2 points. So let's say number 1. I have the points negative 6, 0, and 4, 0. Okay, well, for the distance formula, I need 2 things. To plug into my distance formula, I need the change in x, and I need the change in y. So that's the first thing we're going to find. We're going to find the change in x. We're going to find the change in y. And we did this back whenever we talked about slope. To find the change in x, I'm looking from one x coordinate to the next. So, and make sure you're going from x to x, not x to y or y to x, okay? From x to x, from negative 6 to 4. Thinking about a number line, how would you get from negative 6 to 4? Plus 10, right? Okay, and then for your change in y, from 0 to 0, how would you get from 0 to 0? 0, right? There's no change in y. So, my distance formula tells me I can take the square root of my change in x, quantity squared, plus my change in y, quantity squared. And then all you have to do is go through and simplify. So 10 squared is 100. 0 squared is just 0. 100 plus 0 is 100. And what's the square root of 100? 10. The distance between these 2 points is 10. So this one worked out kind of nicely. A lot of the ones today are going to be decimals, so just a heads up, which is why you have your calculators. Okay, makes sense? Not too bad? Yes?
I have a question. So, like, you know how, like, it's, like, 10 squared underneath the square root sign? The right
Yes.
sign? Wouldn't they just both cancel out?
Now they wouldn't, because there's this addition sign here.
Oh.
That's a good question. That's a great question. So she asked, if you didn't hear, why can't you just cancel out these squares, this addition sign here? If these are multiplication, oh yeah, you could cancel them out. But that addition sign makes things tricky. Okay? Okay, number 2. Next one. We're going to try find the distance between the points negative 5, comma, negative 3. And negative 9, comma, negative 6. Okay, the way that I've found easiest is to find the change in x and the change in y first and then plug them in. If you want to do it all at the same time, I guess you can, but I think it's easier to do it this way. So change in x from one x coordinate to the next, from negative 5 to negative 9. Think about your number line. How would you get from negative 5 to negative 9? Minus 4. And then the change in y From -3 to -6, how would you get there?
-3.
-3. So the distance between 2 points can be found by taking the change in x, quantity squared, plus the change in y, quantity squared. Before I move on, a couple quick things. Notice that I'm squaring the entire thing. This is important because what is this going to do to this number? It's going to make it positive. So what that tells me is after this step, after I simplify after this step, I should always end up with positive numbers. Because I don't care what kind of number you plug in there. If you square any kind of number, positive, negative, it's going to end up being positive. So underneath this square root sign, you should never have a negative number. It'll always be positive. Okay, so 4 squared gives me, -4 squared gives me a positive 16. -3 squared gives me a positive 9. 16 plus 9 gives me 25. And the square root of 25 is? 5. Once again, worked out nicely. Most of them don't. You guys want to try a couple on your own? Okay, I'm going to put 2 of them on the board. You guys try them on your own in your notes. Number 3, -4, 6 and 5, 2. And number 4 is -2, 1 and -8, -5. Okay, so take a second, work those out in your notes. Okay, now some of you are still working. Let's go ahead and finish talking through these ones. So for number 3, my change in x from -4 to 5, how do you get from -4 to 5? Plus 9. How do you get from 6 to 2? Subtract 4. So we're going to plug those in to my distance formula. We should get 81 plus 16, which is the square root of 97, which rounded to the nearest hundredth is what? 9.85. Very good. Questions about number 3? Okay, for the second one, my change in x was what? -6. My change in y was what? Also -6. So we're going to plug a -6 in both spots in my distance formula. So I get the square root of 36 plus 36, which is the square root of 72, which rounded to the nearest hundredth would be what? 8.49? 8.49? Okay. Questions over any of these?